Today we are going to cover two new tools. The first one is the isolation tool. And if we load here, we have retopology and master to start with. This is our retopology character. We can load it. And this is our master character. We can load it here. On the 0 frame, I have the master character. If I move to the 40th frame, I have the retopology character that I'm working on. So that's the way I set up my retopology scene. And this tool helps me isolate areas of great importance so I can see how the loops are moving. For example, if I click upper or lower eyelid, I can get the isolation of that part. And if I hit cluster, I can get that region isolated so I can look at it from all angles. If I move from 0 to 40th frame, I will see how it handles the animation and how the loops move. Does anything need to be adjusted? Do some vertices jump? For example, if I move this, I can see that it's jumping too much and it's bad. And when I finish my editing and I'm satisfied with this, I just need to delete this cluster and everything will go back to normal. My adjustments will be saved. So this is the way that we can isolate certain regions. So especially handy for the mouth. To see from every view. Usually what you will get when you retopologize through some very popular methods like Wrap3D, you will get these kinds of movements. They are not too bad, but they will have an influence on all of the blend shapes that you create with your MetaHuman rig and every expression that you get. So why not put in an extra 15 or an hour just to get something really special. Like this, something usual that you will get because it can't copy everything. And again, just delete the cluster and you're all set to go. Now, the next tool that we are going to cover is MeshNormalize. You can see it here. I'm just going to the master topology. I'm just going to make a copy of it. So when we make a duplicate, we need to be on the 0 frame. And now we can delete history, create a group, call it normalize, hide it, call it master head, and we are all set to go. So on the 40th frame, we have this that we are working on, and we have a copy of the master topology female character. Now we can hide it, click on the head, and get master data. What this tool does is it registers the data that was inputted into the script, and now you have set to master or master normalize. Let's see what that does. If we go to the year part and make a bigger selection, like this, for example, or even bigger, let's select the whole year and the following region and hit set to master. What it's going to do is calculate the differences, and it's going to copy the master data that was inputted here, or rather the master data's vertex position, and now it's identical to this. It's on one-on-one, every vertex. Now let's hide it, and let's go back. So we don't actually need this kind of influence, but let's do a master normalize. Now this whole region is going to get recalculated, and it's going to change a bit depending on the master character. So let's go a smaller region. If we click, you can see everything is moving Once you click that, I have it in the shortcut here. And you have it in the Discord channel explained how to get that shortcut working. So whatever region we select, we can make sure the movement, the distance between the loops, the vertex position is good just by hitting Master Normalize. This tool is very powerful, and and just so you know, the tool is not working with only meta-human topology. It can work with any topology, but for it to work, you need to work on the identical vertex ID counter number. So it doesn't only work on meta-human topology, it can work on custom, but you have to have the master head on that topology as well, or any object. And it's very powerful. If you have something like this, it will help you a lot, like selecting this region and hitting. So it's calculating the differences, and it's calculating the differences on the vertices that are even not selected, like this. So you see here, it's a drastic change. If you want to make sure that doesn't happen, select that part and hit. Now you will always get a much drastic difference on the next not selected vertices or loop. But the way that this works is now you select this, and maybe in the iterations, how many times the operation is going to be performed, just put in a lower number, for example, 1. Make a bigger selection, click this, and you have a better transition now. For a more subtle approach, you can, the coefficient, you can put it to like 0.2 if you're working with scan data, for example, and you don't want your topology to move too much. You can select like this, hit, and this can be 5, for example. So you see it's moving, but it's not jumping too much. It's trying to stay in the same place, but reposition the vertices. So the coefficient goes from 0 to 1. 1 being the highest number, the biggest change that you can get on the character. And the iterations go as high as you can, as high as your computer can calculate, but from 2 to 100 is basically the maximum that I use them. And 100 would be something like if you get like this kind of movement from the eyes, and you want to make sure you get the whole region in a few goes, it will never work on a single click. So you need to click, 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 basically. You see? It needs, when it's a bigger selection, it needs a few more seconds to calculate. Now on the 20, see, it's always trying to figure out the best way to position the loops, or rather the vertices. And on the smaller region, it can go much faster. Basically, it's real time. Once I click it, it does the calculation. And sometimes it needs a bit of movement because it's registering what you selected and the next loop after that. Basically, if everything is bad, it will have a hard time to calculate. But if you have like this, it will give you a much better result. So if you see, this is much better, and the problem is here now. So let's try to get that. So basically having a bigger soft selection and selecting a couple of loops will get you a perfect result like this. Obviously, such work takes time, and you would need to reproject this to the scan, but to get an explanation of how this functions and what is the best approach, you can do it like this. You can see everything is trying to conform because this is a non-human character. it's moving much more than it usually does. Let me see what I will get. Basically, with this, I'm slowly changing the character's overall look and making him more real, because the master data that we are using is a real-life character. We need to have this transition better, but basically, you see, it's much closer to the female master character that we got. You can see a drastic look or drastic change in the 40 frames that we are basically moving the character from. And on the right side, you can see much closer resemblance to the female character. So this tool is very powerful. It will help you in the topology process and save you days of work, but you need to know what you are doing and why you are doing. For example, let's just do this with the nose to see what we will get and have a cleaner version. Let's do like 2 iterations. For a better transition. You see now I don't have any problems on the nose. If I put 100 iterations, it will get much closer to the female character, and that is how the tool functions. Thank you for taking an interest. Looking forward to seeing what you will create with the tool, and see you on the Discord channel. Bye.